Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on the hydrolysis of salts. In our last lesson, we learned about buffer solutions. We demonstrated and discussed the buffer action of acetic acid and sodium acetate. We also discussed an experiment that measures the pH of buffered and unbuffered acetic acid solutions. We discussed that buffer solutions change in pH only slightly when a small amount of a strong acid or a strong base is added. Unbuffered solutions are much more affected by the addition. In today's lesson, we will define hydrolysis. We will explain why the salts of strong acids and strong bases create neutral solutions. We will also explain why the salts of weak acids and strong bases give basic solutions. Students, if you are ready, we will get started. The word hydrolysis comes from the Greek words hydro, which means water, and lysis, which means to split apart. This is quite fitting, considering that the process of hydrolysis is a chemical reaction during which water molecules are split into hydrogen cations or protons and hydroxide anions. The solutions of salts contain two types of ions, including cations and anions. The term salt hydrolysis describes the reaction of an anion or a cation of a salt, or both, with water. The strengths of the parent acids and bases determines whether the cation of a salt will serve as an acid, a base, or as neutral. Students, we can assume that when salts dissolve in water, they are completely ionized. Most salts are strong electrolytes, which means in an aqueous solution, they release free ions that make them electrically conductive. Thus, the acid-base properties of salt solutions are a result of the behavior of their cations and anions. The anions that come from strong acids are weak conjugate bases. As a result, they do not undergo hydrolysis. The strong bases are the ionic hydroxides of group 1A and 2A metals. The cations of these metals also do not hydrolyze. Let us look at an example. Sodium chloride is a salt of hydrochloric acid, which is a strong acid and sodium hydroxide, which is a strong base. Since chloride ions and sodium ions do not hydrolyze, the solution of the salt will remain neutral. Students, this is the formula for potassium bromide. Please write its ionization in solution. Then, predict the nature of its aqueous solution. You may begin whenever you are ready.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. Were you able to predict the nature of potassium bromide's solution? Potassium bromide is a salt of a strong acid and a strong base. The equation for its ionization looks like this. When it ionizes, it forms potassium plus and bromide ions. Since neither of these types of ions react with water, we know that a solution of potassium bromide in water is neutral. Let us continue with our lesson by discussing the hydrolysis of salts of weak acids and strong bases. The solutions of salts derived from weak acids and strong bases are basic. This is because the anion of the weak acid is a moderately strong base. This anion can be hydrolyzed, as you see here. Sodium carbonate is a real example that we can discuss. Students, what are the parent acid and base of this salt? In other words, what are the acid and base from which this salt is derived?
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. If you said that the parents of sodium carbonate are sodium hydroxide, which is a strong base, and carbonic acid, which is a weak acid, then you are correct. Well done. Therefore, just like our hypothetical demonstration, the solution in water will be basic. This is because the anions of sodium carbonate react with water and produce hydroxide ion, as you see here. Students, let us try an activity. In a moment, you will see a list of salts. Identify the nature of the solution of each of these salts as being acidic, basic, or neutral. Try your best and I will see you in a few minutes.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello, everyone. I'm sure that you found that activity to be very simple. Let us go through each salt together so that you can check your answers. Salts A and E both form neutral solutions. Salts B and F both form basic solutions. Salts C and D both form acidic solutions. Were you correctly able to identify the nature of the solution of each salt? If so, great work. If you are having difficulty, do not hesitate to ask your teacher for help at the end of this lesson. In today's lesson, we learned about the hydrolysis of salts. We defined hydrolysis in general as a chemical reaction during which water molecules are split into hydrogen cations or protons and hydroxide anions. We learned that the solutions of salts contain both cations and anions, and that the term salt hydrolysis describes the reaction of an anion or a cation of a salt, or both, with water. We learned that the nature of the solution depends upon the strength of the parent acids and bases. This brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.